In this video, I wanted to build up from some very basic factoring that you'll recall from your previous algebra courses into the more complex factoring problems that you get in your Chapter R homework. So I'm starting with something that you factor without thinking about it too much, most likely, x to the fifth minus x cubed. So the greatest common factor that you can pull out here would be x to the third. We know that because you always factor out the lower exponent, and that's something important to keep in mind. So when you're choosing the power of some common factor to put in the front here, it's always the lower of all of the exponents that you have in your expression. Now, when we write what's left, so if we had x to the fifth, we factored out x cubed, then what's left is x squared. Minus, if we had x cubed, we factored out x cubed, then we just put a placeholder of 1 here. Now, looking back at that x squared right here and thinking about that a little more carefully. So this was initially x to the fifth power, and then we factored out x to the third power. So the reason that you write x squared there is because what you're really doing is subtracting 3, subtracting the exponent that was factored out from the exponent that we started with. Okay, and then in this case, so x squared minus 1, that's a difference of squares. And so this, let me color code this expression here can be factored as x plus 1, x minus 1. And there's the completely factored form for that expression. Okay, so now maybe something a little more complicated. Make my pen a little clearer here. Let's say that we want to factor 3 times the quantity 2x plus 1 squared plus 4 times the quantity 2x plus 1 to the negative 3. Okay, so getting more complicated here in a couple different ways. So first of all, you can identify the common factor here of 2x plus 1. So you know that you can factor out some power of 2x plus 1. Now, when you're deciding which power to factor out, it's always the lower exponent. So in this case, it's that negative 3 power. So this is what should be factored out. Now, figuring out what's left once that's factored out. I'm going to use a hard bracket here, so the square bracket, because I know that I'm also going to end up with parentheses inside of this. So when you have two sets of parentheses, kind of one layered inside another, it's nice to use a different type of bracket so you can see the correspondence, which I'll come back and say more about what I mean there. Okay, but so now figuring out what's left. So we didn't do anything with this 3 out front, so I'm just going to copy that down. Now I have 2x plus 1 here to the second power. I factored out the negative 3 exponent. So since those exponents are different, I know that I have some power of 2x plus 1 left over. Now, when I'm figuring out exactly what power I have left over, we can do the same thing we did in that first example, which is subtract. So here we can say, okay, we started with the second power right here. We factored out the negative 3 power, so you should subtract the negative third power. And so that actually becomes 2 plus 3, so this is 2x plus 1 to the fifth power. Okay, now moving across this expression, I have plus 4, and then 2x plus 1 to the negative third, which is exactly what was factored out here. So there's nothing left of that, so I can just close this bracket. And so here again, this is what I was saying about, I have the square brackets because I had this, the parentheses with the 2x plus 1 inside of it. And so it's nice to use a different type of parentheses on the outside here so you can see that these brackets here correspond and then these parentheses here correspond. Okay, a couple of more steps in simplifying this. For one thing, you should try to write your final answer without any negative exponents. So that 2x plus 1 to the negative third power should be written as 2x plus 1 to the positive third power in the denominator. In the numerator, I'm having trouble changing my pen, we have 3 times 2x plus 1 to the fifth plus 4. In this case, I'm going to leave the expression like that. If it was a lower power, like 2x plus 1 squared, I would multiply that out and combine like terms. But I don't want this video to be 10 minutes long. So since that's the way this one ended up, I'm going to leave it there. One last factoring problem for this video. So dealing with another layer of complexity here. Let's say you have x plus 11 to the 3/2. And I believe this is one I took out of your My Math Lab homework. So you should have a very similar problem somewhere in your homework. But so I have x times 3/2 times x plus 11 to the 1/2. Box that example out. Don't really need this note. Okay. So here we've got this common factor of x plus 11. So I'm going to factor that out. Always take out the lower exponent. So if I compare 3/2 and 1/2, the lower exponent is the 1/2 power. Now figuring out what's left in here. So I have x plus 11 to the 3/2 initially. I factored out the 1/2 power. So there's some power of x plus 11 left over here. If we do that same subtraction approach to figure out the exponent that belongs here, it would be 3/2. That's the power that we had initially. Take away 1/2. That's the power that was factored out. That leaves you with 2/2, which is first power. We don't typically write, if the exponent is 1, then we don't write anything in the exponent place, but I'll write that there just for clarity. Then we have plus x times 3/2, which I will write as 3x/2. And then x plus 11 to the 1/2, which is exactly what's factored out. So I don't need anything there. So now in your final answer, we shouldn't really have the fraction here. We should probably combine these terms. So to do that, I would multiply the numerator and denominator here times 2. So multiply by 2/2 here so that you can combine those terms inside the brackets. Let's see if I can bump this up. Yes. So this is, x plus 11 to the 1/2, which is the same as writing the square root of x plus 11 times, okay, so what we have inside the brackets there, both terms are over 2. So I can write this as a single fraction with 2 on the bottom. On the top, we have 2 times x plus 11 to the first plus 3x. Now here's what I was saying in that last example about how you should multiply things out and combine like terms. I'm going to do that here. So if you distribute the 2, so this is square root of x plus 11, and then you have 2x plus 22, that's 22, sorry, plus 3x all over 2. Or if you want, you can think of it as this is over 1. Whoops, this is over 2. So when you multiply straight across, this will be our final answer. You have the square root of x plus 11, 2x plus 3x, so this is 5x plus 22, all over 1 times 2, which is, 2. And this would be your final answer.